Okay, today we are going to do this. Okay, how do you differentiate arc sine x? So when you differentiate this, I think you still remember, you get 1 over square root, then 1 minus, okay? Then because this is x, so we have this is x, and then we have the square like this. Is it? This is what you get when you differentiate. So how to show this? I repeat. Actually, we have done this before. You let y to be equal to arc sine x. So you want to find dy dx. Differentiate. So you have sine y equal to this. Differentiate sine y implicit. Dy dx. This one is explicit. You get 1. Then dy dx is equal to this. But sine, you know sine y is x. So you use the identity, you change, and then you get the cos y is this one. So that you substitute. That's why I get this. That's why when I differentiate arc sine x, I will get this. This one we have learned before. And then I told you already what is the difference between differentiate and integrate. So when I bring this one over, it becomes integrate. So that means you integrate this one, you will get arc sine x. Okay. Okay, next, cos, same thing. Differentiate arc cos. What do you get? You let y to be this, okay, then cos y, differentiate this one, implicit. You have this one, negative sine, dy dx equal to 1, and your dy dx is equal to this. Okay, so therefore, you see, and then you substitute, here you use the identity. Okay, so you differentiate arc cos x, you get that is here. I straight away take it from here. I get negative sine y. So I substitute the sine y to become like this. That means you integrate this one negative. Differentiate this one, you get negative. That means you integrate the negative, you will get arc cos. Or you bring the negative over, that means you integrate this, you get negative arc cos, or you get positive arc sine. Okay, so you go through this one, and then after that we have another one, the arctangent, isn't it? So we have another one, the arctangent. So you differentiate arctangent, you let y to be arctangent, and then you want to find dy dx. So from here you differentiate tangent, you get secant square, dy dx implicit. Then this is explicit, you get 1, therefore you get this. But you know secant square y is 1 plus tangent square y. So your dy dx is 1 over 1 plus x square. Okay, because your tangent y is x. So this is 1 over x square. Okay, differentiate this is 1 over x square. Therefore differentiate arctangent is 1 over x square. You see x. Okay, therefore you integrate this one, you will get arctangent. Okay, you will get arctangent. So you just remember this. Okay, now you remember, if the sign is like this, you look at the red color, you have 1 over square root, 1 minus, and then square the red color, then it will become arc sine, then x, or it will become negative arc cos, then x, same. Okay, so likewise, if let's say the bracket here is not an x, because if this is x, you differentiate the x, you will get exactly 1, isn't it? But let's say this is not x. Let's say this is, you have, this is 3x. So you differentiate 3x, you must have a 3 here. So you must add a 1 over 3. It's the same one. But you differentiate this. Then this one will become 1 over 3 like that. 1 over 3, then this is arc sine, then 3x. Or is negative. Or if is negative, then because we have 1 over 3, then this one is 3x like that. It's the same. The bracket still maintain the same. 3x. But because this is 3x, you must have a 3 here. That's why you must add a 1 over 3. Okay? So if this is 4x, then here you must have a 4. So you must have 1 over 4. It's the same. Then this, all the red things will change into arc sine or negative arc cos. So same thing here. If you have something like this, you remember 1 over 1 plus, because this one we cannot factorize. If 1 minus x squared, you can factorize. If this is minus, you can factorize to be 1 plus x, 1 minus x, then you can use partial fraction. But this one you cannot factorize. So this one is arctangent x. So same thing. If here, because you differentiate, you get 1. So if let's say I give you a bracket, this one is not x, something else, something else. Then when you differentiate, you want to integrate this, you will get arctangent the bracket. So if this bracket is, let's say this bracket is 10x, so here also 10x. And then what must be on the top there? Should be a 10 here, so it's 1 over 10. So the answer here is 1 over 10. Understand? So it's just like this. So you have to remember the pattern. When you see this, then it's arc sine or arc cos, like this, something like this with a square root sign. If something like this is arctangent. But if this is negative, then you use partial fraction. Okay? But I tell you here, I just remind you, of course the question won't ask you to, what happen if like this? The question will never ask you this, because this one is not in your syllabus. Okay, this one integrate, you get a hyperbolic function which is not in your syllabus. Okay, so you just remember what 1, 2. You just remember 1, 2. Okay, so now I give you example. Okay, let's say you have this. Okay, look at one by one. You look at one by one. Let's say we have this. The first one we have square root 1 over square root 1 minus 4x squared. That means if you see this, when you see this, it must be negative. That means it is same like this one. Okay, it is the same like this. So it is the same like this. So what must we do? You must change. So this one can be written like this. So now the bracket become what? The bracket, this one bracket, is it 2x? So when you want to integrate this, you will get, you want to integrate this, you must have a 2 here. So you add a half. So it's half, and then integrate this like this. The red color, all this will become arc sine 2x. Or it can be negative. Okay? So this is the shortcut methods. Okay? Okay, if you want this one, you just, what I mean, from here to this one, you memorize, isn't it? You memorize it. Ingatkan, pay that. Okay, but what happens if, let's say, you want to show, you don't want to memorize, you want to show. So like this, you get like this, so it's the same, you change like this. So you want to show, because this is arc sine, so you just substitute this bracket, if you want to show, always you substitute this bracket, 2x to be sine theta. You use integration by substitution. So you substitute 2x to be sine theta. So you substitute. Then you differentiate. 2 dx equal to, differentiate sine theta is cos theta d theta. That means your dx will be half cos theta d theta. So you substitute. So 1 over square root, this is sine theta, 2x is sine theta, that means sine square theta. And then this one you substitute, you get this. Okay, then after that, this one is cos square theta. Okay, square root of cos square theta is cos theta. That's why cos theta you can cancel. Therefore you get a half here, and then you integrate theta, you d theta, you get theta. Okay, so what is your theta? You see sine theta is 2x. Okay, we have already substituted on top here. That means theta will be arc sine. So you get this answer. You see, it's the same one. Exactly the same here. Exactly the same. But this one you memorize. This one you show the step. So I tell you, in case the exam asks you to integrate this, you must show all these steps. You don't do like this. This is when you have no, when you solve question, you solve a question, they give another question, you solve until finally you get this. Then maybe you can use this way faster. Okay, but if the question come out like this, ask you to integrate, you must show. Okay, because usually they will give you 5 marks or what. If you do like this, how to give you 5 marks? Huh? So many things here you memorize. Okay, now we go to the next one. Let's say like this. Okay, of course the 3 you take out. Then you see when you want to do this one is same like this, with the square root sign and minus. Okay, with the square root sign and minus, and then this one must be 1. So because it must be 1, we take out the 4. So we take out the 4 will be 2, isn't it? When this 4 is taken out, is 2. So I took it out, and then here I will have 4 already taken out is 1 minus 9x squared over 4. So I must change into a bracket like that. So when I want to change into a bracket, it is like this, isn't it? Now the bracket is this one. So when I integrate this, I will get arc sine or negative arc cos of this bracket. So, but what happened is here on top here I must have 3 over 2. So I divide by 1 over 3 over 2. You see or not? So when you divide this, it will become 1. This one is 1. So when you integrate this is arc sine. This all the red color with this, and then with the square root 1 minus, and then all the square, you get arc sine, then the bracket. Or it can be negative arc cos. It's up to you, but usually we take arc sine. Or like this, both also correct. Okay, so now I just want to show you how to use, how to show the steps. This is the shortcut memorize method. This is in urgent case. Okay, here same, he take out and then the 4 also take out, so you get this, and then finally you will get this. So just now I just straight away I integrate, isn't it? But now you want to show. So you want to show, you just substitute this one as sine theta. You see or not? I substitute this one as sine theta is 3, the bracket, the whole bracket to be sine theta. Then I differentiate sine theta with cos theta d theta. Differentiate this as 3 over 2 dx. So the dx will be 2 over 3 cos theta d theta. So what I do is I substitute 3 over 2, I substitute, sorry, this one I just not substitute, I just bring down. Then I substitute here, this is sine theta, becomes sine square theta, and then 2 over 3 cos theta d theta. And then you see that you can cancel, all these can cancel. And then this is actually cos square theta, square root of cos square is cos theta, and then cancel again. That's why I get theta plus c. Okay, then after that you see sine theta is this, because from here, that means the theta is arc sine of this, so you get arc sine of this. So same answer, isn't it? Okay, so if let's say you want to get arc cos, you want to get the answer to be arc cos, then you just let cos theta to be 3 over 2x, then you will get arc cos. You just let this. Okay, now after that you look at this one. Now look at this one. This is a fraction. This fraction is proper fraction. This is proper. So we can integrate. It's a proper fraction. We don't have to do long division. So this is a proper fraction. But can you factorize? Cannot. Unless this is negative, then you can factorize. Though cannot factorize, you cannot use partial fraction. So if you try to use integration by substitution, also cannot. And then of course integration by part is out, because this is not the combination of two functions. This is only algebraic. Okay, there is no exponential here or whatever. So what we do here, you have to change to become like this. This one, number 2, same type. So you take out the 9, you get like this. Okay, now you get this one, the 9 you take out, and then here 1 plus, this is 4x over 3 square, everything like that. Then because I want to integrate this, the top I must have 4 over 3, so I must have 1 over 4 over 3. So this one I simplify, I will get this. And then because it's 1 over 1 plus x squared, I'm using this. Okay, I'm using this. That's why it's arctangent, the bracket. So here I simplify, I get 1 over 12. This is the answer I get. But this one is from this step to this step, memorize. Okay, there is no working here. So if let's say you want to show the working, you have time, or the question asks you to integrate, you must show every step. So you want to show the working, same, you make it like this first, exactly like this. Then only you substitute. Here, because you know this is arctangent, that's why you substitute this one as tangent theta. Then you differentiate tangent, you get secant square theta. This is 4 over 3 dx. Therefore, your 1 plus tangent square. Secant square is 1 plus tangent square d theta. Therefore, your dx will be 3 1 plus tangent square theta over 4 then d theta, isn't it? Okay, then we substitute everything back here. Then you have this 1 over 9. You have 1 over 9, bring it down. This is 1 over 1 plus, this is tangent square theta. Then substitute the dx is 3, 1 plus tangent. And then you simplify. After that, this one also can cancel. You see or not? Then you get the 1 over 12, you take out. Then here you remain only 1. Therefore, when you integrate 1, you get theta. And then from the top here, tangent theta is this one. So your theta is arctangent. So you substitute. That's why you get this. You see the answer is the same. But here with all the steps, the complete steps, complete working. This one no, this one just skip a lot of what we call the integration parts. Okay, then after that you look at this one, let's say we look at this. You want to integrate ex square root 1 minus e to x. Okay, so if you try using this, you try using this. Let's say I want to use this method. That means the first method, this is negative half. This is 2x. Okay, so when I want to integrate the negative 2x, I will get 1 minus e 2x half over half. I will get this. But here I must have what? Differentiate this. Differentiate this, I must get negative 2. That means e to x is not x ex. So this is wrong. That means this ex you have to take out, isn't it? You have to take the ex out. Then you so because I differentiate this, I get negative 2 e to x. So I add an e to x here. Then I divide by e to x. Then this is already wrong. I told you already. This part is correct, but this part is wrong. That's why cannot. So you cannot, what must you do? Of course, you cannot use partial fraction. You cannot use substitution, okay? You can go and try. So what you do like this, negative ln 2, 0. Then this is 1 minus, like this, square ex. So when you see something like this with the square root 1 minus ex square, then you try using the arc sign. So can we use arc sign? You see, this one I differentiate, I will get this, isn't it? You see, when I differentiate this, I will get this. That means I can use the arc sign. That's why you see I show you all the red color so that to make you realize this one can change into arc sign. Then it's ex, negative this one to this, and then you substitute e0, e negative this, then e0 is 1. Then arc sign this one, I bring the half up here, become a negative, up here become half. Then this one cancel, therefore I get half. And this one I get 1. And then after that, arc sign 1 is pi upon 2, 90 degree, half is 30 degree, so I get this. Okay, but this one, again, memorize this part. So you want to show the step, same, like this. Okay, then you substitute this one. Substitute this one to be sine theta. Okay, so you want to substitute sine, you don't use a cos. So differentiate sine, you get this. Okay, then after that your dx will be this one, and then you substitute. You see? Okay, then the limit also you must change. Okay, so when x 0, you see I show you here. X is this one. I just show you how to change this one. So when your x equal to 0, the top one, then this one is pi upon 2. Then when x equal to negative ln 2, you get ln, here just now x equal to 0, you get 1 is pi upon 2. But when x equal to negative ln 2 is ln half. So this one, so your theta is, sine theta is half, theta is pi upon 6. That's why I substitute here. Pi upon 2, pi upon 6, then ex, then 1 minus, Okay, ex square is sine square. Is sine square theta. Then this one I substitute. Okay, why I don't substitute this? Because I can see they can cancel. Then this is cos theta, cancel. Then you get this, then you get theta, then you substitute. Then you get the same answer. Okay.